class. So today I'm going to discuss the unit of measurements or the standard unit of measurement. This is a continuation of what we have discussed last meeting or last video. So measurement is very essential in the formulation of hypotheses, theories, and laws. It provides three kinds of information. First is the size or the number, a unit, and the indication of the uncertainty of the measurement. Numbers or number in the measurement are represented in decimal form and or scientific notation. So units such as liters, pounds, and centimeters are the standard of comparison for measurements. So without units, a number can be considered insignificant, unclear, or delicate. So for example, a medical doctor prescribes a 100 milligram of antiviral drug 3 times a day. So it means that you need 300 milligrams per day to kill the virus inside your body. But if a single dose of 100 milligrams takes more than 10 times, or let's say 1,000, you took 1,000 milligrams per day, it would be dangerous. So now let's move on to standard of measurement or the standard system of units. So it was established in France in 1795 and was adopted by the International Agreement in 1960, and it composed of 7 base units. So the International System of Units, also known as the SI. So every type of quantity measured in SI has a base unit and a symbol for that unit. So most other nations use a system of measurement based on multiple of tens. So before SI unit was formed, every country has its own unit of measurement. Like for example, in the Philippines, we use salop in buying rice. So salop is an estimated or has an estimated volume or mass of 2.5 kilos. So we are also use dangkal, dipa, and so on and so forth to estimate the amount or the length of an object. So now we have SI units, we are now able to get the exact amount of length or the amount of any object. So these are the base units under the standard unit of measurement. So we have meter for the length, kilogram for mass, second for time, ampere for electric current, Kelvin for temperature, mole for amount of substance, and candela for the intensity of light. But in this video, we are focusing on length, mass, time, and temperature. We also have discussion or separate discussion about the amount of substance. So what is conversion? So conversion is being used by the scientists in order to go from one unit to another. For example, we have kilograms to grams, seconds to hour, and then etc. So these are the logo of the standard unit of measurement. So first on the list is a meter. So meter is used to get the length of an object. So remember that SI is based on powers of 10. So therefore, that 1 meter is equal to 10 decameter. 10 decameter is equal to 100 centimeter, and 100 centimeter is equal to 1,000 millimeter. So metric rulers and meter sticks are used to measure length. So next on the list is the kilogram. So kilogram is used to get the mass of an object. So grams and milligrams are used for measuring objects of small mass. So the first question is how many grams are in 1 kilogram? So there are 1,000. So there are 1,000 grams in 1 kilogram. So for you to convert easily, we have a ladder method. So ladder method is a technique It is a simple way to establish the different metric classification. It is produced by using numerical prefixes by the names of the units. Like for example, you are converting kilograms to grams. It has a definite amount of the original unit. So the use of the ladder method with the metric conversion, this is the simple way to know the different metric classification. So these are the common standard unit prefixes. And then let's proceed to ladder method. So these are the steps in ladder method. So number one is locate the starting point. Then sum up the jumps to your ending point. Number three, move the decimal point to the same number of jumps in the same direction. So if from a smaller unit to larger unit, use the upward. So in the ladder method, we need to move upward. Then move a decimal point to the left, like this one. Then if a larger unit to the smaller unit, use downward ladder. Then move decimal point to the right. So for example, we need to convert 125 ml to liter. So milliliter is here. This is the last step in the ladder method. So we need to move 3 upward. So 1, 2, 3. So here it is, the liter. Okay, so then the decimal point of a whole number 125 is at the end of the number 5. Since the SI unit is from ml to liter, move the decimal point to the left. Okay, so 1, 2, 3. So the answer will be 0.125 liter. So next example is 0.90 grams. So convert 0.90 grams to milligrams. So locate first the grams. So here it is. Convert to milligrams. So this is the milli. Okay, so we need to move 3 downward. 1, 2, 3. So 0.90. So we need to move this decimal place to the right. So 1, 2, 3. Fill the missing area. So that is 900 milligrams. So the answer is 900 milligrams. So now we know how to use the ladder method. Now let's move on to choosing a unit. So the size of the unit you use to measure with will depend on the size of the item being measured. So for example, if you need to get the area of the court, so you need to use the kilometer or the meter. So how about the baseball bat? So when we use the baseball bat, we need to use meter or inches. So how about the coins? So we need to use the millimeter or the centimeter. Okay, so now I will test your knowledge by converting the following values using the metric ladder. So I will give you a minute to answer these values, and after a minute, we will check if your answers are correct or not. So your time starts now. Okay, now let's check your answer. Okay, for number 1, convert 687 kilograms to milligram. So first we need to locate the kilogram and then the milligram. So count 2, 3, 4, 5, 6. So we need to move the decimal place from left to right. Now, so 6 times. So 687 kilograms. So this is the decimal place. So 1, 2, 3, 4, 5, 6. So we need to fill the empty places with zeros. 5, 6. So the answer is 687 million. So number 2. So number 2. So number 2 is 0.9999 grams convert to kilogram. So this is grams convert to kilograms. So we need to move upward. So count 1, 2, 3. So we need to move the decimal places 3 times from right to left. Okay, so 0.9999. So 1, 2, 3. So now this is the place where we find decimal place. So the answer would be 0.0009999. So that is the answer for number 2. So how about number 3? So number 3, 7 liters to milliliters. Number 3, liters. Here it is, 2 milliliters. So we need to move downward. Then count 1, 2, 3. So we need to move the decimal place from left to right. So 3 times. So 7. This is the decimal place. So 1, 2, 3. So we need to move 3 times. So 1, 2, 3. So the answer is 7,000 milliliters. So next, number 4, 5.5 meter to centimeter. Okay, so meter, here it is. Then centimeter. Centi, so we need to move 1, 2. Then downward. Okay, then 5.5. Move the decimal place from left to right. Okay, so 1, 2. So fill with 0. Then the answer is 550 centimeter. Then number 5. Number 5 is 23.56 milligrams. So milligrams. So this is milli and convert it to gram. So we need to move upwards. So the step or decimal place is we need to move from right to left. Okay, so 23.56. So this is the decimal place between 3 and 5. So 1, 2, then 3. So the answer is 0.02356 grams. So I hope you got all perfect score. So next, we need. So now let's move on to the standard unit for time, which is seconds. So there are 60 seconds in a minute and 60 minutes in an hour. So therefore, how many seconds in an hour? So for this question, we are going to use the long conversion method. Now we are not using the ladder because the ladder method is only for or only intended for metric system. So today or so for this question, we are going to use the long conversion method. Okay, so following this format, so first is we need to 1 hour. So times 60. So there are 60 minutes in 1 hour. So in 1 minute, there are 60 seconds. So 1 minute, so there are 60 seconds. So we need to cancel out the minute, and the minute to get how many seconds in 1 hour. So we need to multiply 60 times 60. So the answer is 3,600. So there are 3,600 seconds in 1 hour or in 1 hour. So these are the units under time. So 1 minute is equal to 60 seconds, 1 hour is equal to 60 seconds, and there are 24 hours in 1 day. So now let's proceed to the standard unit of measurement or the SI base unit for temperature, which is Kelvin. So 0 degrees Kelvin is the coldest possible temperature, also known as absolute zero. So that is negative 273 degrees Celsius, which is 273 degrees below freezing or below freezing point. So temperature refers to the heat content of the matter, which can be measured. Temperature can be measured in degrees or on the Celsius and Fahrenheit as the two common temperature scales using this formula. So to get the Fahrenheit, so we need to use this formula. So when we need to get the Celsius from Fahrenheit, we need to use this formula. Okay, so for example, what is the temperature in Fahrenheit of 20 degrees Celsius? So we need to use this formula to get the Fahrenheit. So I will rewrite this for you to understand better. So 9 over 5. So this is fraction degrees Celsius plus 32. Okay, so 9 over 5. So what is the value of the degrees Celsius? That is 20. Multiply by 20 plus 32. Okay, so you can input this fraction 9 over 5 as is in your calculator, or you can use the PEMDAS to solve this one. So we need to solve first the division before multiplication. So 9 over 5 is equal to 1.8. multiply by 20 times plus 32. So 1.8 times 20 is equal to 36 plus 32. Then 36 plus 32 is equal to 68. So the answer for this question is 68 Fahrenheit. So for example number 2, what is the temperature in Celsius of 60 degree Fahrenheit? So using this formula, we will try to answer we will try to convert 60 degree Fahrenheit into Celsius. So I will rewrite this again for you to understand better. So 5/9 multiplied by degree Fahrenheit minus 32. Okay, so 5/9 is equal to, or 5 divided by 9 is equal to 0.56. Then multiply by 60, the value of Fahrenheit or the temperature minus 32. Then 0.56 times 28 is equal to 15.5555 or 55. Then round up is equal to 15.6. So this is your answer if you use the manual computation, but if you have a scientific calculator, the answer is this for the fraction, or 15.56. So this is the same. Using scientific calculator, your answer is 15.56, and using manual computation, also the same, 15.56. Okay, so the answer is 15.6. So it's review time, class. So for this slide, we are going to review the learnings that we acquired during our discussion. So first question, convert 120 kilometer per hour to meter per seconds. So before the start of the computation, we need to find the equivalent. So how many meters in 1 kilometer? So there are 1,000. So there are 1,000 meters. Then how many seconds in 1 hour? So that is 3,600 seconds. Okay, so 120 kilometer per hour. So we need to write here the 1 kilometer to cancel out the kilometer. So how many meters are in 1 kilometer? So there are 1,000. So 1,000 as numerator. So 120 multiplied by 1,000 is equal to 120,000 meters. So we are done with the meter. Now let's proceed to hour. So hour is equal to, 1 hour is equal to 3,600 seconds. Then 120,000 multiplied by 3,600 seconds is equal to 33.33 meter per second. Okay, so question number 2, if a watermelon weighs 1.5 or 1.50 kilograms, how many pounds does the watermelon? So this is the solution. So there are 2.2 pounds in 1 kilogram. So 1.5 kilogram times 2.2 pounds is equal to 3.3 pounds. So this is the answer. So this is the end of chapter 2. I hope you just learned something for this video. So thank you for viewing and listening.